Hi, my name is Thomas Pollard. I'm currently studying a graduate certificate in information technology. Today I would like to present to you my major project in the course IFQ551, Computer Systems Fundamentals. The content covered in the Computer Systems Fundamentals course was very extensive, and from this I chose technologies to create a project using Raspberry Pi as my CPU and incorporating hardware, software, and web technologies. We will get to these later. Firstly, my objective. My objective in this project was to build an automated procedure using Raspberry Pi, which reported on and recorded my dog's movements. I chose this project as I was very interested in my dog's activities, particularly at night and in the middle of the day whilst I am at work. In doing this, I wanted to create a system which could be used beyond this course, as I wanted to be able to study and analyze patterns in my dog's movements and behaviors and to post results online. From a computer systems viewpoint, inspiration behind this project was to combine several techniques and technologies learnt throughout this course and to link various hardware and software products and techniques in a practical environment. Now, let's look at the equipment and technologies used in this project. Firstly, my dog, Kevin. Kevin is a 4-year-old toy Labradoodle. Kevin is a very energetic dog, and he loves to go out and play in the backyard, which he accesses through the doggy door. The hardware. Raspberry Pi was the central processing unit used in this project. I had heard of Raspberry Pi prior to this course, and I was very keen to learn more about it and utilize it for a project. I had heard of the many hobby projects which can be done using Raspberry Pi, and from some of these examples I decided on my project. Raspberry Pi functioned very similarly to a standard PC, and I learnt a lot about CPUs and their multiple components while setting up and using my Raspberry Pi. These two images show the setup of Raspberry Pi as provided in the course modules. The image on the left shows the kit that was provided as part of the course pack, and the image on the right shows how Raspberry Pi looks when fully set up and connected. The other hardware used in this project was the motion detector, which I purchased online. When I received my motion detector, it came with wires to be able to connect it to a Raspberry Pi. I was to connect these two together, and then I was required to set up software to enable the two pieces of hardware to communicate with each other. The motion detector was to be placed next to the doggy door for this project, which is only used by Kevin. This image shows the motion detector and the Raspberry Pi connected together. This turned out to be a challenge encountered in this project, which I will discuss shortly. The software. Operating systems are considered the most important software that runs on the computer, as it allows for communication from the user to the computer in a way that both the user and the computer can understand. Raspbian was used as it was the operating system that was part of the Raspberry Pi setup, and it was used in all course modules. It has been developed specifically for use with Raspberry Pi. Python programming. I chose Python as the programming language for use in this project for a number of reasons. The main reasons were due to my prior experience in using it, albeit brief, the libraries contained within Python, the large number of resources available for developing and troubleshooting Python code, and the relative ease in understanding the code. Despite this, Python programming was one of the most challenging sections of this project. Web technologies. The aim of this project was to post something online at each detected motion, and so Twitter was chosen as the platform to post these messages on. Twitter could be connected to Raspberry Pi through the use of Twitter APIs, which stands for Application Programming Interface. APIs are programs which allow for communication between software. In this case, it connected Raspberry Pi to Twitter to allow for the program to access account information and post through this Twitter account without the need for prompting the user to log in each time. The process. Using online resources, I researched and sourced Python codes for detecting motions using my motion detector and displaying a message, and also tweeting various messages via Raspberry Pi. An example code was found for each of these components, and this was then modified and tested for my project. Firstly, I tested tweeting from Raspberry Pi. After setting up my Twitter API account, I found a tutorial which included Python code to tweet a simple message from Raspberry Pi. I then modified this to include my unique authorization keys, access tokens, and passwords, and to display a message in theme with my project. This was a great success, as seen on the image on the left. I then tried changing this message again, which was another success, as seen on the image on the right. Upon revisiting this project the next day and repeating the process, I came across a 403 error message, which then occurred every time thereafter. I could not work out why, as I had changed nothing in my code. After a lot of research and looking closely at the error code created, I discovered that Twitter does not allow APIs to continuously tweet the same message. I then tested that this was the source of the error by changing the tweeted message. Bingo! Hello Kevin was returned, and the first major hurdle of my project had been overcome. The next step was to program the two hardware components to talk to one another in order for the motion detector to report on motions. Again, a tutorial was sourced which included Python code, which was then modified and simplified. I tested by moving in front of the motion detector, however I received no message in return. Upon looking closely at the hardware, I realized that one of the 3 wires from the motion detector had a loose connection. I took the device to an electronics store for advice, and it was confirmed that new wires were required. Upon reconnecting the hardware and moving in front of the sensor, motion detected was printed. This taught me the importance of quality hardware and connections. After this success, it was now time to merge these two programs into one. Through a lot of research, trial and error, and modification, these codes were merged into one file with the first resulting tweet shown here. This was used as the base code, and it was then modified and personalized in order to improve the outputs of the program. This slide shows the full final code, which is quite hard to read given the size of the program. The first part of the code set up the components to be referenced later in the code, including importing Python libraries, opening the CSV file, and importing my Twitter API details. It also set the value of the variable dogInside to true, which was set up to set whether the dog was inside before the motion or outside. This variable was called upon and edited later in the code. Once these components had been set up in the code, the remainder was all one loop, which would continue until I pressed Ctrl-C on the keyboard. Inside the loop, the code responded to detected motions. The response depends on the values of the 3 variables: current state, previous state, and dogInside. The variables current state and previous state changed in values depending on whether motion was being detected or not. Whilst no motion was being detected in the motion detector, the value of current state would be 0, and this would change to a value of 1 upon a detected motion. After a motion was detected, the outputs were created by the code, which were to post a tweet and to write a line to the log file. The contents of the tweet and the log would say whether the dog went in or out and at what time that occurred. The time was initially not planned to be part of the tweet, however it meant that the tweet was different every time, thus solving the issue we had faced earlier where an error code would come up if too many tweets with the same text were posted. Another variable, s, defined the value to be posted on Twitter and to be logged to the CSV file, and it differed depending on the value of the variable doginside. The line doginside equals true set the file up so that it was starting the tweets in the correct order. After each motion, the not command was used, which changes the value from true to false and vice versa. The line doginside equals not doginside alternated the value for doginside between true and false. The result of this program was two different outputs, which occurred every time Kevin left the house through the doggy door or returned inside through the doggy door. One was the creation of a CSV file, which was updated at every detected motion, which was stored locally and called upon later. The other output was a new message tweeted at every detected motion. Both outputs contained a message which indicated if the dog was going inside or outside, at what time of day, and on which date. The biggest challenge in this project was programming. I chose Python as the programming language as I had experience using it in the past. However, I had never used it for anything as complex as this. Python also had a massive amount of information and tutorials available online, and through this I was able to develop my final code. I learnt a lot in doing this process, and I hope to continue to develop my programming skills in the future. The hardware connection challenge was another big hurdle to overcome in this project, and as mentioned earlier, this was overcome with the key lesson being in the importance of quality connections and quality hardware. Despite being very happy with the results of this project, there is always room for improvement. As my understanding of both computer systems and programming increases, I would like to revisit this project and see how I would approach it differently and possibly improve upon the end result. One hardware and software improvement which would be very interesting in adding to the project would be the addition of a second motion detector. The benefits of this would be that the program could then incorporate the direction of travel determined by the order in which the sensors detected motion, and the speed, which could be determined by the time taken between the two detected motions if the sensors were placed at a known distance apart. Another possible improvement from a hardware perspective would be to adjust settings within the hardware of the motion detector, thus ensuring that motions detected outside of a certain range of distance or outside of a certain signal strength were excluded from the results. I would like to also revisit this project using as many different techniques and technologies as possible. I am confident that I could use a different CPU, a different operating system, a different programming language, a different motion detector sensor, and a different web technology, and I'm confident that I would still be able to achieve the same outputs as this project. From a results and analysis perspective, I would love to use the motion detected for a long period of time at the doggy door to enable a detailed study into my dog's movements, behaviors, and patterns. I plan to do this beyond this experiment. Overall, I found this project very challenging yet very rewarding. Through a combination of software, hardware, and web technologies, the objectives of this project were met, and the end results far surpassed my expectations for the project. During this project, I learned a lot about these components and the linkage between them. This really reinforced the theoretical components of this course and helped provide a very practical resource for future use as a result. Thank you for watching and listening.